5 levels of LLM apps. Consider this to be a framework and help you decide where you can use LLM. There are a lot of different myths around what LLMs can do, what LLMs cannot do. Where do you use LLMs today? So I decided to put together this material in which I'm going to take you through kind of like a mental framework based on the extension or the depth in which you go towards an LLM. You can decide where you can fit this LLM. So we're going to first see what are those different levels of LLMs that I have put together. Then we are going to see slight extension of that. Got two different documents to take you through that. So this will give you an idea about how LLM is being used today and how you can use LLMs for your own applications. To start with, imagine this pyramid structure. This is a very simple pyramid structure. And as you can imagine with any pyramid structure, the top of the pyramid or the peak of the pyramid is our aspirational goal. And what you see at the bottom is the easiest that we can do. And as with everything else, you have to slowly climb to the top of the pyramid so you can probably hit the aspirational goal. So to start with, where do we use LLMs first? Q&A, a question and answering engine. What do I mean by that? It is quite simple for us to understand. So question and answering engine is a system where you have an LLM and all you are going to ask the LLM is a question. So you send a prompt and the LLM takes the prompt and gives you an answer. That is it. That is the entire transaction that you have between an LLM. Send a prompt, send it to the LLM, get an answer. LLM, large language models, are nothing but sophisticated next word prediction engines, and they have been fine-tuned with something called instruction. So they're instruction fine-tuned models. That means they can take a human instruction and get you an answer back. For example, if I ask a question for this, what is the capital of India? Then the LLM would process this, and then LLM has information about how to answer it, and then it will give me the answer back. The capital of India is New Delhi. That's all what you're going to do with this thing. So first level, question and answering. Now you might wonder at this point that where can you use question and answering as an LLM engine? This is the first thing that people built, like when LLM started, even back in the day, GPT-2 level, people started building simply Q&A bots. So all you want to do is ask a question, give an answer. Could be a homework, could be a general knowledge question, could be something about the world, could be about science, could be about anything. Ask a question, get an answer. As simple as that. It's a very 3-step process. Ask a question or send a prompt, take the LLM to process it, give me the answer back. Very simple application. Now what you're going to do is you're going to add something to that application, and that is how you actually build a conversational chatbot. And to understand this better, I would like to take you to my second document, which will give you probably better idea. Whenever we are talking about LLM, there is one important thing that we need to understand is we have crossed the stage where LLM is simply a large language model. We have more than that. So for you to understand that, I have 5 dimensions: a prompt, a short-term memory, an external knowledge, tools, and extended tools. If you think of this as your horizontal, these are your verticals. These are different dimensions that can add to an LLM. So you have a prompt, you have a short-term memory, you have a long-term memory or external data, you have tools, and you have got extended tools. So let me give you an example for each of this so that you can understand this better. A prompt is, what is the capital of New Delhi? That's all the prompt is. You simply go give what is the capital of New Delhi, and the LLM understands it and gives you a back understanding, just gives it back. Now, short-term memory is when you have conversational history or something in the LLM. That is what we call as ICL, in context learning. So whatever you stuff inside the context window, the LLM can take it. That is your short-term memory. So you give a few short examples. You give an example, like for example, what is the capital of US? I guess it's Washington, DC, and you give a bunch of examples like this, so the LLM knows what is that it has to answer. This is a short-term memory. Next, you have external data. Now you take data from Wikipedia and you keep it and then give it to the LLM. That is your long-term memory, because short-term memory, just like a computer, the RAM, it gets reset every time you reset the conversation or the session. And then tools, you let LLM use tools like calculator, internet, Python, terminal, and all these things. And extended tools is when you expand this much beyond that. I hope now you have understanding about the 5 different dimensions that we have in LLMs: a prompt, a short-term memory or in-context memory, a long-term memory or external knowledge, external data or custom knowledge, tools like calculators and Python REPL, and extended tools that goes much beyond that, what we do not have currently. So these are different dimensions. Now coming into what we wanted to see is chatbot. So how do you make a Q&A bot as a chatbot is very simple. Now at this point you might have already got this idea. So you take a prompt and you give it to the LLM where you can have short-term memory, in context memory and in context learning. For example, so what is the capital of India? So what is the capital of India, you ask, and the LLM answers New Delhi. This is what happens in a simple Q&A bot. But how do you make it a conversational bot or a chat bot? By adding a new dimension called short-term memory. And how do you do that? You keep all these things that you are conversing into the chat conversational history. So what this gives the ability for an LLM to do is, when you say what is the capital of India, it says New Delhi, then you can just simply go and say what are some famous cuisines there. So at this point, the LLM would have an understanding you're talking about New Delhi because that conversation is stored there in the LLM's short-term memory or the in-context memory. So the LLM can do something called ICL, in context learning, and give you the response back. And that is how you upgrade in the pyramid by building a Q&A bot, giving a new dimension called history, and then making the Q&A bot a chat bot so that it can converse. Now, chatbot has applications everywhere that you can turn towards. You have got chatbot in customer support. You have got chatbot on websites. You have got chatbot for education. Like you've seen a lot of demos from Khan Academy. So chatbot is quite versatile. It almost has its purpose in every single business or domain that you can think of. Now, people were using chatbot, but chatbot itself is not enough. Why? We already know the answer to the question. Can you pause and answer if you know the answer? So why is that chatbot is not enough for a lot of use cases? The answer to the question is chatbot stops with only short-term memory. You need long-term memory or you need external memory. See, for example, I ask what is the capital of India? It says New Delhi. What are the famous cuisines there? It will give me an answer. Quite valid. LLM is doing its job. So let's say I'm a company. Okay, so I'm an organization. Let's take Apple for an example. Okay, now I ask who is the CEO of Apple? Of course, the internet has information about it, so it will say Tim Cook. That's quite easy. Now, if I go say who is the manager of the team handling iPhone 16, will it answer? No. I mean, it might answer because it hallucinates a lot, but the answer would not be correct. And that has become a big bottleneck in a lot of enterprise use cases, because you do not just need internet knowledge. You do not just need the knowledge that the LLM has got. You need more than that. And that is the custom knowledge component or the external knowledge component that you need, the dimension that you need to make your LLM slightly more than just a chatbot. And that is where a new technique called RAG comes into picture, retrieval augmented generation, where you use the knowledge that you provide, or you call it a long-term memory. You use the documents, the internet, the sources, everything that you have around, and you use that knowledge to send to route to LLM, and then make the LLM leverage that knowledge. And now at this point, probably you might have guessed it. See, first we had only prompt, 1 dimension. Second, we had short-term memory, 2 dimension. Now we have external knowledge, which is 3 dimensions. So this LLM is at the center of 3 different things. You have got prompt, you have got short-term memory, and you have got long-term memory. To make you understand this better, so I'm going to take you to the RAG. So how does the RAG look like? So you have got the LLM at the center of it. You have got your data somewhere available. So it could be on different structures. It could be on database. Most organizations have data in their database, structured database, RDBMS database. Then you have got documents which are unstructured like PDF, HTML files, internal portals, blah, 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 blah. Then you have got APIs. Let's say you are a sales team, probably your data is in some CRM or Salesforce, right? So you need a programmatic call to make the call and get the answer back. So your data could be of these different places. Could be like structured database like RDBMS system. It could be unstructured documents, PDFs, HTML documents, anything that you have locally. And then you have got programmatic access, like you're a marketing team, you need data from Google Ads. You're a sales team, you need data from Salesforce. Your company is heavily into IT, so you need data from AWS, like billing cost and all other things. So this is programmatic. So you use one of these methods, a structured parsing or unstructured parsing, a programmatic call, and take all the input data and create an index. An index is what Google creates at every single moment. You have got all these websites. What Google does is Google creates this index. So it is easier for Google to go traverse when somebody is asking a question, and that's how Google became popular. Before Google, people were using totally different thing. Google came up with something called PageRank algorithm. At the fundamental of PageRank algorithm, you have got this index with the different parameters, of course. And definitely we are not building Google. So index is what we are building. It makes it easier for you to understand what is inside the data. So now a user comes in, asks a question. What is the question? Who is the manager of iPhone 16 team? So that question goes to the index. This system, particular system, takes that and picks only the relevant information. See, this index might have information about all the teams. iPhone 16, Apple Vision Pro, billing, accounting, procurement, marketing, blah, 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 blah. So it has all the information. What you are interested in is only this particular piece, which is what you asked, which is iPhone 16 manager. So this particular part is where it takes only the relevant information from the index, and then it matches with the query, the prompt that you give, and then it finally sends it to the LLM. The prompt, what you asked, and the data that you extracted, and it goes to the LLM. LLM gives the answer back to the user. This is quite different from the chatbot application. If you see, I'll give you an example why. So in the chatbot, all you are doing is you have a memory, question is there. Sometimes you might do, let's say, a long-term memory by doing user profiling. I'll ignore this for now. You don't have to use this now. Ignore this for now. So what you're doing is you have a question, you're sending it as a prompt, and you have memory that also goes to the prompt, because that's how you can do it. And you have LLM answering this question and you get the answer back. Now you might ask me, hey, why do I need to put my thing in the external data and create an index? Rather, why can't I keep it in memory? If you have got this question at this point, that is a very important question and you are thinking in the right direction. In fact, people who reached at this point, you can tell me whether you know the answer or not. The reason why we cannot do this or we could not have done it early in these days of LLMs is due to an important factor called CTX window. What is CTX window? CTX window is nothing but called context window. This internal memory and question, or the short-term memory and the question, is bounded by what is the context window of this particular LLM. So you have an LLM, the LLM might have context window like 4K, which is quite popular these days, or 8K. And even Gemini like LLMs have like 1 million as context window. So context window is there. Now what you are actually doing here is you have a question, the LLM answers. So you have a question 1, right? And answer 1 comes back. Then you have a question 2. Then you have answer 2. By the time you go to question 3, what you are sending to the LLM is not just your question 3. You are actually sending all these things, right? So let's say this is 2K. This is 1K answer. Then again 2K question, 1K answer. And let's say this is a 2K question. So at the end of the day, when you are hitting the third level of conversation, I'm kind of exaggerating, but let's say 2 plus 3, 2 plus 1, 3, 3, 6, 8. So you've already hit 8K. So conversation context window. So if you have got 8K token model, at this point your model will hit out of memory error, or it cannot hold it in short-term memory. And that is exactly why you need RAG, retrieval augmented generation, because this one is not bound by the conversation. Of course, you are going to keep it in conversation, but you don't have to stuff everything inside your question. Rather, you can keep it inside your index, right? Because you've already indexed and you can keep it, and only the bit that is relevant comes to you. And now you might be asking, how is that possible? And for that, you go into like a separate tangential side that talks about semantics and semantic search and all the other things, embedding semantic search. That is quite out of scope. If you want to go deep, you should read RAG. Llama Index is an excellent library for you to read about RAG. They have got really good developer relation system. They have got a lot of articles and you should definitely read about Llama Index and RAG if you want advanced RAG. But I hope you get the point. Going back to our system that we put together. So what do we have? We have a Q&A system at the front, which just takes an input, gives an output, nothing else. Then you have got the chatbot, the input plus history goes together. That is always short-term memory. You get the output also goes back to the input. That's why you keep the conversational history. Then you have got a RAG, retrieval augmented generation. The reason why it is called retrieval augmented generation is because you have got a retrieval component that you augment with the LLM component and then you generate the response back. So that is retrieval augmented generation, and the applications are enormous. There are a lot of startups in 2024 when we are recording this, a lot of startups just doing RAG. So if you can build a RAG solution today in 2024, you can probably even raise fund or you can be a good successful SaaS. There are a lot of companies making really good money, solid money out of it. I'll give you an example. In fact, like one thing that I've seen, sitegpt.ai. If you go to sitegpt.ai, it says make AI your expert customer support agent. And I know this is a product that is making a lot of money, hundreds and thousands of dollars. And at the foundation of it, it is a RAG. It takes all the information that is available in your website, indexes it, or we call it data ingestion and indexes it. And when you ask a question, it just gives you an answer back. That's it. It's not just a normal chatbot. It is a chatbot that can answer based on the existing data. So if you are breaking into LLM today, I would strongly encourage you to do some RAG system. That is by default something that you should do. So if you're a university student watching this, if you're an early in career professional, I would say you should build a couple of RAG examples so you know. There are a lot of nuances in RAG, like how do you improve indexing? How do you improve indexing by changing chunking? What kind of algorithms you use for embedding, and what kind of models are good with RAG? Whether you put the text at the top, is it good? Whether you put the text at the bottom, is it good? If the text is in the middle, it is good. There are a lot of components to RAG. RAG is not just simply what we discuss usually on this channel. You can go advanced RAG, and I would strongly encourage you to spend some time in RAG, unless you want to get into something that is quite exciting and interesting. But before we do that, I would like to quickly show you one more thing that not a lot of people discuss when we talk about LLMs. It is not necessarily RAG. It is just like using short-term memory. So it doesn't use long-term memory, but it has its own potential, which is to use LLMs, large language models, for classical NLP tasks, classical NLP downstream tasks. For example, let's say you want to build a text classification system. What is a text classification system? You give a sentence, for example, the movie was complete crap. Now, is it positive or negative? Positive or negative? You choose, you train a text classification model just to figure out this. For example, or the other example I can give is you have a review. Let's say the movie was amazing and the actress was exceptional. Now you try to build a model that will say what kind of review is this. For example, is this review about movie, theater, or director, or actor? So now you know this is an actor based. So this is what text classification in classical NLP is. There are a lot of other tasks that you do in classical NLP. What you can do is, without having to build your custom model, like let's say BERT based model, XGBoost based models, you can use LLMs, large language models, for classical NLP problems, because large language models are really good in context learning. And with the current memory that you have got, with a few short examples or a tree of thoughts or a chain of thoughts, you can make your large language models a good zero-shot NLP classifier, or it is applicable for a lot of other tasks as well. So one thing that not a lot of people are exploring, I would encourage you to explore if you work in classical NLP problems like labeling or a text classification, entity recognition, whatever it is, you can leverage LLM. Now the question is, do you want an LLM based solution? That's a different topic. I'm not talking about, you looking for a nail because you have got a hammer. I'm just saying that this is a good opportunity. Wherever you don't want to build models, you can use this. But of course, if you can build models, that will be probably cheaper than, making calls to LLMs and getting answer back. But summarization, text classification, entity recognition, I think LLMs are exceptional zero-shot LLM and downstream tasks, and you should definitely leverage it. Now with this, we have arrived at RAG. Okay, so we have arrived at RAG and we already know what is RAG. Now we are entering into a very interesting phase about what everybody is obsessed with, what everybody's love: agents. Very recent announcements from Google, Microsoft, previously OpenAI. In every announcement, you would have seen two important things as a common trend. One is you would have seen multimodality. Multimodality. What does it mean? It just simply means instead of just chatting with text, you can chat with images, you can ask questions in voice, it can respond back in speech, you can send videos. So one important trend that you're seeing is multimodality. And the second important trend that you see everywhere is agents. Multi-agent setup, where you have got multiple agents, you can summon these agents to do certain tasks, and these agents will do it for you. Just like Men in Black, MIB. They have a purpose and they will do certain tasks. But before I jump into agents, I want to actually introduce you to another important concept called function calling. Function calling is the precursor to LLM agents. In function calling, what you do is you have a short-term prompt. You have short-term memory. Sometimes you need external memory, sometimes you don't need external memory. But you are giving the ability of calling external tools. And you are giving the ability of calling external tools by doing something called function calling. Function calling, to be honest, is a terrible name because you're not calling any function here. You're not making the LLMs call anything, not at all. All you're doing is you're forcing the LLM to give a structured response back so you can call an LLM. I'll give you an example what is function calling. So let's say that you have a weather API. Okay, weather API. I think everybody goes with weather API, so I'm going to skip. Let's say you have a currency converter. Okay, currency converter. What kind of things a currency converter need? Okay, you need input currency, you need output currency, you need date, you need amount. Technically, these are the four things you need. What is the amount that you want to convert for? What is the input currency? What is the output currency? And what is the date for which you want to do currency conversion? Let's keep as a simple API. Now, typically when you go to an LLM, okay, and say, what is USD to INR today? First of all, LLM may not understand what is today. LLM might know USD, LLM might know INR, but LLM's memory is frozen because it's a snapshot. See, a large language model is a snapshot. So its memory has been frozen to, let's say, September 2023 or something like that. Okay. So what it cannot do is it cannot give you the latest information, and you cannot do this with, I mean, you can do this with RAG, kind of like you can every day take knowledge, ingest, keep it in your memory and then give it back. Not very efficient. Expand this to stock market, but daily data doesn't matter because everything changes like every minute and every second. So you need something instant. What do? You call an API. If you're a programmer, that's what you would naturally do. You call an API. Now, if you want to call an API, what you need to call an API. So let's say this is the information. What I need at the end of the day, I want to call it currency converter, right? And I'll say input, output, date, amount, right? I need to make a call like this. So I need 4 arguments. That is solid. Input could not be like, oh, United States, dollar, and some other time I'll be like USD, some other time I'll be like US dollar. I mean, that will not work, right? You need a specific format for everything. Your, let's say, amount should be an integer, right? This should be a data object. So you need to force this LLM to give you a particular response back. Otherwise, what happens is this LLM will throw you anything. For example, what I want to say is, what is USD and INR? So I'll be like, oh, USD and INR is so on September 2023. So you have to guide the LLM to make a particular type of output. And somehow universally everybody has accepted that format is going to be JSON, except Anthropic, which absolutely loves XML. So if you use Anthropic, you use XML. If you use any other model, you use JSON. So you're forcing an LLM to give you a structured response back, a JSON that can help you make this function call. You can call this function with that JSON. So a guided response into a JSON is what everybody calls function calling. You don't necessarily call the function in function calling, but you get the output that will help you call function call, right? Clear? Now that is exactly what is a precursor to agent, because in a function call, you have the ability to call a function, and agents are nothing but a bunch of function calls stitched with tools. So what do we have in agents? We have a bunch of function calls plus tools. And I would like to introduce to you a very interesting solution that can help you understand more about agents. If you're too old in the AI world, you would have probably recognized this immediately. And this was the workflow of something called Baby AGI. So Baby AGI was quite a popular thing back in the day. I mean, back in the days, like less than 1 year before, I guess, or maybe more than 1 year. A function call is what I said is the foundation of agents. But what is an agent? Now, if you have seen our pyramid, you would know our agent sits right at the top, like closer to what our aspirational figure is. Now, what is this agent? How do you define an agent? So it's simple. First of all, a chatbot and a RAG, all of these guys, if you see here, they end at text or some kind of thing like input, output, images, video, all these things, right? That's where they end. One of these modalities, they're done. What you achieve with agent is something that is absolutely stunning. You don't stop at text response, you stop at an action. You trigger an action. And that is what agents are simply. You take LLM, you connect them with tool, you give them a purpose or a goal. That is your agent. And that is exactly what Baby AGI has done back in the day. Like there are multiple agents now, but if you see Baby AGI, which is a very wonderful framework, you can see that there is a task, like there is something that has to happen. There are certain tools, like for example, Vector DB and all the other things are there. And every agent has a purpose, like, okay, you have to execute, you have to return, you have to do something, you have to do something, and they have a goal. So you have tools, purpose / goals, and LLMs, and this all together work for a common goal, and that is your agent. There are multiple agent frameworks that are quite popular these days. Crew AI, LangGraph, you have got a PyAutogen, and most of these things you will see. First, you have to define a role. You have to define a goal, a role, goal, and then you have to say which LLM that you want to use as a backend engine. And then you put together a system of one, this is single agent. Now you put together like this is a team, that is your multi-agent setup. With agents, people are doing amazing things. You can make an agent book your ticket. You can make an agent, let's say, read something, distill something, create a note, publish the blog post. You can summon these agents to do a lot of things. And personally for me, the most time that I spent reading about agents, because it's becoming quite obvious that agents are the next frontier in the way we can take LLMs forward. I mean, there are a lot of different things, but at least personally, I'm quite interested in automation usually. And I think agents are going to be the next big thing in, I mean, currently itself is a big thing. Google has got Google's own projects, like they call their own agents. I don't know what they call. They have a lot of different names. OpenAI has its own agents, And every time you talk to some company, you speak about agents because you want to summon these agents. You want to connect these LLMs to like different dimension, and this dimension that what we are connecting is the tools dimension. So you take LLMs, you have the function calling ability, and once you connect them to tools, you are unlocking the potential of something immense, and that is what you call as agents. I'm not going deep into agents because this is probably, I'm hoping it to be a series depending upon how you all like it. But in this series, my next focus is going to be agents. So agent is quite closer to the top, and that takes us to the almost the end of the video, which is what is our aspirational thing? What is that we are all trying to go towards to, which is LLM OS. And this is inspired by Andrej Karpathy, who created this amazing structure. So what is happening here? This talks about using LLM at the center of a conversation, or sorry, center of an operating system. If you go back in the day, computer was created just for simple calculation purpose, right? You want to add A and B. You want to keep A for 1 and B for 2, and then you want to add them. That's what like initially computer was started, like very back in the day. Then computation started increasing. Computation started becoming less expensive, more compute. Then we have the computer that we have today. Andrej Karpathy is arguing, can we have a similar vision for LLM? And where the vision is, you keep LLM at the center, right? You keep LLM at the center, and at the center with LLM, you have RAM, which is the short-term memory or the context window. Then you have long-term memory, the disk system that can be used with RAG. Then you have the agent structure that you have with the tools, and then you connect it with internet, and when you connect it with other LLMs to have like a multi-agent setup or like a peripheral setup. And then you have your peripheral devices where you have got audio and video. Can we put together a system with all these things working towards a common goal, and that will ideally become your large language model operating system? This is quite a vision at this point. There are certain implementations available at this point. Those implementations are based on current understanding. They are mostly, let's say, LLMs plus function calling plus agents, multi-agent, more tools. That is what the current LLM OS is. It's not like a radically has a different total view altogether. And that's why if you see even in my framework that I've created, LLM OS is currently developing, and it is everything that we have got. The tools, the extended tools, the peripheral tools, with long-term memory, with short-term memory, with just one input from the user where it can run itself and then it can execute certain things. I think that is the future that we are heading. I'm not sure when we are going to do it, but if somebody says something AGA for me today, AGA could be like, this could be like the baby AGA. I mean, I don't trust AGA as a concept anytime soon, but yeah, leaving the consciousness and all the other things out, I would say LLM OS is at the top where we can expect something closer to AGA happen, and all these things lead us up to there. So I wanted to keep this video brief, but this video is already going to be like more than half an hour. I wanted this to be like a crash course where you understand. If you don't know anything about LLM OS, maybe you have not taken any course. So this is going to help you to see how the future of LLM OS is coming and what led us up to there. And let me know in the comment section if you like this kind of content. I'll put together more. This took me a lot of time to create the framework, design, put it in a particular thought process to make it understandable. And this is basically what a lot of LLM courses offer. So I'm definitely looking forward to hear more feedback. And if you like this kind of format, subscribe to the channel. See you in another video. Happy prompting.